Finally, let's have a look at a present value question. You can read about present values on page 45 of your textbook. We are going to calculate a present value of a stream of future values. This image here tells you generally how we're going to do it. There's some numbers in there already. So assume we get $100 this year, $100 next year, then $150 the year after, and etc., etc. They are future values. You get $50 in year 4. You get $50 in year 5. But we only care about present values. So we can discount these future values by dividing them by these terms. Take note, they're identical except for the exponent here. That number is determined by the period you're in. So in period 1, so this is period 0 now, period 1 is to the power of 1, period 2 is to the power of 2, etc., etc. Let's have a look at a simple example to illustrate this. Do you know what an annuity is? An annuity is a financial product. You buy an annuity by putting down a lump sum now, and that gives you the right to some future stream of income. It's an investment product. So say we buy an annuity, and I buy it in year 0, right now. This annuity will pay me $200 in year 1, $200 in year 2, $200 in year 3, and then it'll stop because that's the term of the annuity. I have an interest rate or a discount rate of 20%. Now, this future value of $200 is not the same as the present value of those $200. We need to discount them. We need to find out what these future incomes are valued at in the present. So we take those future incomes, 200, 200, 200, and we divide them by the discount factor that we saw on the last page. 1 plus R. In this case, R is 20%, or 0.2. So 1.2 to the first power, 1.2 to the second power, 1.2 to the third power. I do these simple calculations and I end up with these values. I add them together and I end up with this. That is the present value of the ability to receive $200 per year for 3 years starting next year. Or another way to look at this is, I would buy this annuity now for no more than $421.29. I've just figured out the price of an annuity that'll pay $200 per year for 3 years starting next year at that interest rate. So, it could be an annuity, it could be a cost, it could be a benefit. It's just a number that you've got to calculate a present value for, regardless of the context. Okay, the last thing I wanted to talk about is on the same page, but it's this question here. What happens to a present value when the discount rate changes? What happens to a present value when the discount rate changes? And that's what this table here shows us. This is the $200 payments and what they're valued at in the present at 20%. These are the numbers we just figured out, at 20%. Let's increase that discount rate from 20 to 60, which I've done in this row here. And take note that when I increased the discount rate, the present values decreased. So there's an inverse relationship between the discount rate and present value. As one goes up, the other goes down. Thanks for watching, folks.